In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Today I'm going to discuss my lecture number first on normal operation of FCC unit. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose or not from my tongue, that they may understand my saying. Allahumma Rabbi zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay. Fluid catalytic cracking FCC unit, lecture number 1, normal FCC operation. Okay, key takeaway points from lecture number 1 on normal operation of FCC unit. First, we are going to discuss today a process control guidelines. On later stage, we will discuss reactor and regenerator heat balance, convergence, gasoline selectivity, C3 and C4 recovery, off-spec handling, slope handling, set point list for main process. Okay, unit normal operation. To stabilize the FCC unit, so we need to understand reactor variables and their control mechanism. The first reactor variables, number 1, raw oil charge rate as desired. Number 2, raw oil preheat temperatures set to balance coke yield, conversion and gasoline round numbers requirements. Lift steam normally set at 2-8% of the design fresh feed rate and is not normally changed. May be used at high flow rates during startup and emergencies. Steam to feed distributors typically 2 to 2.58% of the fresh feed. Reactor temperature adjust to obtain desired conversion and gasoline round. Reactor pressures directly set by main column receiver pressures. Reactor catalyst level set to cover the top steeping grid assuming a catalyst density of 640 kg per meter cube. Steeping steam use just enough to steep the catalyst of residual hydrocarbons. This quantity can be arrived at observing the effect of decreasing the steeping steam rate has on the regenerator temperatures. A rate of 1 to 2 kg per thousands a kg pound of circulating catalyst is atypical. Naphtha or gasoline risers used to assist catalyst circulation during startup and to control the regenerator temperature when the unit is behind in burning. Okay, regenerator variables and control mechanism. The first, combustion's air rate control. Adjust for sufficient air to burn the coke of the spent catalyst. Maintain 1 to 4% excess oxygen in the flue gas. Number 2, low regenerator combustion temperature. Adjust for a proper coke combustion. Reactor regenerator differential pressure. Adjust to obtain stable slide valve differential pressure. Slide valve differential pressure depend on reactor regenerator pressure and catalyst levels. Overrides are normally set at 0.14 bar G or 2 psi. Upper regenerator catalyst level. Maintain a minimum level which will result in stable operation in order to minimize the catalyst inventory. Torch oil rate used during startup to aid in the catalyst inventory heat up. To use of the torch oil should be minimized for the protection of the catalyst. Air to catalyst cooler. Normally set to remove enough heat to control the upper regenerator dense phase temperature 725 degrees Celsius. Okay, FCC unit normal operations. process control guidelines, fractionation section variables. Number 1, a main column receiver pressure. Adjust as required by the reactor pressure, regenerator differential pressure, and the relative main air blower discharge and wet gas compressor suction pressure. Okay, overhead receiver temperature generally is maintained in the range of 40 to 45 degrees Celsius. Main column temperature set to control the endpoint of the unstabilized gas stream. Main column reflex rate vary to control the tower top temperature. This rate depends on the amount of the heat removed from lower section of the column. Cycle oil circulation rates set as required to transfer heat in associated heat exchangers. Main column bottom circulation rate adjust to balance the main column heat removal. The hot bottom circulation flow is used to minimize the bottom residence time to prevent a corking. Main column bottom temperatures adjust to quench a rate for the 365 degrees Celsius maximum bottom temperatures to prevent a corking. Okay, unstabilized gasoline yield depends on the charge rate and conversion. Light cycle oil product rate depend on the charge rate and conversion and is varied to obtain the desired properties of LCO. That's known as light cyclic oil. LC stripping steam rate adjusts to meet a product flash point specification. Last, a main column bottom product rate adjusts to control the main column bottom level. Okay, gas concentration sections, unit and normal operation process control guidelines. Number 1, wet gas compressor and what would be its operating conditions. Section valve open away from limiting stop as spillback. Number 2, high pressure receiver. So the temperature must be maintained at 40 degrees C. The pressure rides on a primary absorber, a back pressure. Primary absorber intercooler a maximum of 40 degrees C. Intercooler flow rates as needed for good absorption efficiency. Rides on sponge absorber back pressure. Sponge absorber lean oil flow rate as needed for a good absorption efficiency. Do not flood tower. The pressure is controlled to give a good absorption efficiency and hold correct back pressure on high pressure receiver. Steeper. Overhead flow is controlled by heat input to column to give a sufficient C3 and hydrogen sulfide steeping. Rides on high pressure separator back pressure. Okay, debutanizer. Trade 10 controls reflex to give desired RVP of light naphtha. Top reflex temperatures should be as cold as economically possible. Reboiler heat as required to give a good fractionation. The pressure must be high enough for condensation of C3-C4 steams by air fin fans and a cooling water system. Okay, this is my last slide. Next slide we are going to discuss what we have concluded. Okay, conclusion. Today we have discussed the control parameters of reactor, regenerator, fractionation sections and gas concentration section. Okay, next topic. Next topic we are going to discuss reactor and regenerator heat balance. That's a very important topic. Okay, references here. The first, Qatar Petroleum, Doha, Qatar. Oil and Gas Development Corporation Limited, Pakistan. World Energy Outlook 2013. U.S. Geological Survey. U.S. Department of Energy. Schlumberger's Oilfield Glossary. International Energy Agency, IEA. Wikipedia. Oklahoma State, a marginal or well commissioning pumpers manual. State oil fact sheet, Injured. Mossack's Standard Norway. The Story of Oil in Pennsylvania. Air, Liquid Gas Encyclopedia. Natural gas from wellhead to burner tip. Okay, together everyone achieve more. Certainly, everyone, if we work hard, and definitely we will achieve more. Thank you very much for your precious time. Please do not hesitate. Send me your feedback and comments t.masood.dr@bath.edu. Many thanks and stay blessed. God bless you all. Thank you very much.